Okay. Hi, my name is Sarah, and today me and my groupmates are going to be talking about the regional geology of Asian countries in Nepal, because our country of choice is Nepal. So the content of this video presentation will cover the introduction and tectonic settings, which is going to be presented by me, the stratigraphy by Cher, the rock units by Olivia, and the structural geology and geological resources by Faye. So without further ado, let's dive right into the introduction. So the country of our choice is Nepal, and it's a South Asian country. It is home to the largest peak in the world, known as Mount Everest, and it is also known as Sagarmatha by its locals. The height of the peak is measured up to 8,848 meters, and what's great about this country, fun fact, is it has a very unique flag shape. And when I mean unique, I mean unique. Okay, so the country of Nepal is located in between India and China, and the Himalaya mountains cover about 75% of the country, and by 75%, I mean really much all of it. So if you see right here, in brown right here on the map, that's the Himalayan mountain ranges, and it covers completely Nepal. And if you see right here, the Himalayas passes through other countries such as India, Pakistan, Afghanistan, Bhutan, and China, from you can see in the map right here in this diagram. What's great about the Himalayas is that the Himalayan mountains have acted as a natural barrier against the interactions between people, preventing war. So if you look at the picture before this, it actually prevented war between the Indians and the Chinese people. And that's what's really amazing, it's fascinating. Next, we could talk about the formation of the Himalayas. Now, the formation of the Himalayas is actually due to tectonic activity, and that will be covered in the tectonic setting, which is also going to be presented by me after this. And the the convergent plate boundaries that occur here is the interaction between continental plates to continental plates. So the thing about the Himalayas is that it's still considered one of the few youngest mountain ranges in the world, and that's crazy because the youngest is considered 40 million years old. Without further ado, let's talk about the tectonic settings. Now, the tectonic setting of Nepal is a rather interesting story, and that's because it begins with two plates. Those two plates are the Indian plate and the Eurasian plate, and tectonically speaking, the Himalayas are the product of the collision between the Indian and the Eurasian plate. And I chose this picture because you can see that the motion of India is moving upwards. Okay, so if you look at this GIF, you can notice that the process of subduction is actually occurring. And this is because the interaction between these two continental plates are convergent plate boundaries. I mentioned before in the introduction that the convergent plate boundaries in Nepal is continental to continental. That's the relationship between these two plates. As they push against each other, it builds pressure and it builds up the mountain ranges. And the processes that occur are compression, folding, and uplifting. And these processes will be further explained in geological structures presented by Fayola. Okay, so the Indian plate subducts under the Eurasian plate, and this occurred around 40 to 50 million years ago. But the subduction is still occurring to this day. It's just very, very slow. If you see right here in this image, this is actually a cross-section between the Indian plate and also the Eurasian plate. You see right here. If you see in this picture, I chose this because it shows the motion of the Indian plate, and as it moves upwards in that direction, you can see that the red lines here is actually where it's subducting, and that's where the Himalayan mountains are formed. So now I'll be talking about the chronological order of how the tectonic setting is taking place. It all started 60 million years ago, and what happened 60 million years ago is how the Indian plate starts to approach the Eurasian plate, and it moves in an upwards slowly by 4 to 6 centimeters. And the most important event that occurs is the collision between the plates. It hasn't started yet, but it's only starting now. And you can see that over here, it's actually separated by the Tethys Sea. Moving forward to 40 million years ago, and the heavy sediments, which is around here, on the ocean floor begin to sink underneath the Eurasian plates. And because the Indian plate is such lower density, it begins to subduct underneath the Eurasian plate. And what happens here, yes, it closes the Tethys Ocean, if I already mentioned. Yeah, the important event is the closing of the Tethys Ocean. Moving forward to 20 million years ago, the Tethys Ocean is completely disappeared now. It's gone. It's not there anymore. The heavy sediments from the seafloor are pushed upwards to form the Himalayas. As said before, if you notice, if this is the collision between the plates, and if you look at me making weird awkward hand motions, you see the Indian plate, okay? The Indian plate moves underneath and subducts, and causing the sediments to go upwards, if that makes sense. I'm not sure if I'm explaining this really well. That's why I showed you these pictures. So the Indian plate begins, okay. The Indian plate begins to subduct, and the heavy sediments from the seafloor are pushed upwards to form the Himalayas. Going on to today's time, with GPS technology, it's so advanced, you can see that India continues to move upwards. It's still moving, like I said, the subduction, the plates are still moving, and it's moving towards 18 millimeters per year. That's little, but if you consider it, it's actually the same rate as our fingernails to grow, and the Greater Himalayas is constantly growing up to 5 millimeters per year due to the constant motion between India and the Eurasian plate. And small earthquakes and tremors still occur to this day. And what's crazy about this beautiful, gorgeous mountain, is that it is a product of collision. It's the product between the collision of India and the Eurasian plate. That's all for me. My name is Sarah. Now you can move forward to the stratigraphy.
Next, I'm going to present the stratigraphy unit of Nepal. For Nepal, there are 4 subdivided zone morphotectonic, which is the Sub-Himalayan, Lesser Himalayan, Great Himalayan, and Tibetan Himalayan. Let me start with the Tibetan Himalayan zone. It is a formation that starts from Cambrian age until Eocene and consists of metamorphoses of sediment rocks. Then, there are Sub-Himalayan zone that is Neogene age and consists of sandstone, shell, and conglomerate. The third one is Great Himalaya that consists of kyanite, sillimanite, and schist that age from Proterozoic. Lastly is Lesser Himalaya. I'm going to elaborate more about Lesser Himalaya because it was located in between the Greater Himalaya and the Sub-Himalaya. The location of Lesser Himalayan can represent the layer and age of the other two. From the table, we can see that Lesser Himalaya started from late Precambrian until early Miocene, and from the left side of the stratigraphy, we could see there are stratigraphic subdivision for Lesser Himalayan. First subdivision of it is the Nawakot complex, which also divided into 2, which is Lower Nawakot and Upper Nawakot. Lower Nawakot have 5 formations, which is the Kushma, Ranimata, Uleria, Sangram, and Galyang formation. And for Upper Nawakot has only 2, which is the Shanjia and Nakarpata groups. It is known that Nawakot is the first layer and the oldest layer, which started from the Precambrian until early Paleozoic. Gondwana unit is the next layer after Nawakot complex, which aged from Jurassic until Paleocene that consists of sandstone, black shell, and quartz pebble. The last layer, or the younger, is at the Tertiary unit, which aged from Eocene to early Miocene. To summarize all the formation, we can see it from the stratigraphy table that shows about the Sub-Himalayan, Lesser Himalayan, and the Great Himalaya.
Okay, now let's continue with the rock unit parts. So, as we can see here in this slide, this is the geomorphic unit of rock unit in Nepal. Overall, this rock unit has all the rock types, which are igneous rocks, sedimentary rocks, and metamorphic rocks. So for the first part here, the yellow part is terite unit. That's the recent age, and the rock types that is found here is alluvium. In the northward, it has the coarse gravel, but gradually becoming finer to the southward. So Next is Dune Valleys. Dune Valleys is located in the middle of Siwalik Range. The edge of this unit, also the recent edge, has the rock types of fluvial sediments as it located within the Churia Hills. The third part is Siwalik Range. This unit has the edge of mid-Miocene to Pleistocene. Basically, the rock types that found in this unit is sedimentary rocks such as sandstone, mudstone, shale, and conglomerate. So the purple part here, which is Mahabharat Range, it has the edge of Precambrian and Paleozoic, but occasionally also contains Cenozoic edge. This unit nearly has same edge with the Midlands unit also, but the Midland has the edge of Precambrian and Paleozoic to Mesozoic. These two rock unit has igneous rocks, sedimentary rocks, and metamorphic rocks. For the metamorphic rocks, these two units contains non-foliated and foliated metamorphic rocks. So for the foliated metamorphic rocks, examples are such as phyllite, schist, and gneiss. And for the non-foliated is quartzite. Proceed with the 4 Himalaya. 4 Himalaya has the edge of Precambrian, also same edge with higher Himalayan. These two rock unit has the same rock types, which is a higher grade of metamorphic rocks such as gneiss, schist, and marbles, but the difference of both of these rock unit is all of the rock types in the 4 Himalayans are belonging to the lesser Himalayan zone. Meanwhile, the rock types in the higher Himalayan, the rock types are belonging to the higher Himalayan itself. The last part here is the blue one, light blue here in this slide, is inner and trans Himalayan valleys. This rock unit has the edge of Precambrian and Cambrian to Cretaceous. This unit has the rock types of higher grade of metamorphic rocks and also contain Tethyan sediments such as limestone, shale, and sandstone. And all of these rock types are belonging to the Tibetan Tethys zone. That's all for the explanation of rock units. Next part is structural geology, will presented by Fayola.
Hi, my name is Fayola and I will present about the structural geology. So the regional structural geology of western Nepal to the south of the South Tibetan detachment system is controlled by 6 major thrust systems, which are main frontal, main boundary, Ramgarh, Daderdura, and main central thrust system. So based on the diagram here, the main frontal is also the sub-Himalayan thrust system, contains 2 or 3 sheets composed mark of the main frontal thrust. Secondly, main boundary thrust system. The main frontal thrust system is truncated by main boundary thrust and overlaying by lesser Himalayan rocks as seen in the diagram. So for Ramgarh thrust system, it is defined as major fault system where green-chest grade rocks of Kushma and Ranimata formation on top of less metamorph lesser Himalayan rocks. Ramgarh thrust also placed at upper tertiary rock sand beneath Daderdura thrust. Now is Daderdura thrust system. It is marked by North Daderdura thrust. It is contiguous with South and North Almora thrust. Lastly, main central thrust, also the Greater Himalayan zone. This zone is expressed topographically as a major increase in elevation from 3,000 to 5,000 meter and more. There are foliation in the Greater Himalayan rocks parallel to foliation in the underlying lesser Himalayan rocks. Generally, the Himalayas are rich in minerals. The Kashmir has the greatest concentration of minerals. Minerals that can be found in Himalaya are mostly metallic metal deposit, non-metal, few minerals, and decorative minerals. There are oil deposits in places like Bhutan, Nepal Gange, and Dailek, while natural gas can be found in Mustang, the Kamandu Valley, and several other places in Nepal.